So when you have an equation that has a square root in it, you can eliminate the square root by squaring both sides of the equation. Because this one has two square roots in it, that means we get to have double the fun. We're probably going to have to square both sides twice. Sometimes it could be avoided, but sometimes it just can't. So what I would prefer to do is take one of the square roots and put it on the other side before squaring both sides. So I'm going to leave the square root of 2x minus 1 on the left side, and then add the square root of x minus 4 to the other side, and then square both sides. So when you square the left side, the good news is it gets rid of the radical. When you square the right side, you do actually need to multiply it out. So the left side is only going to have 2x minus 1, no more square root. And on the right side, it's going to have the square root of x minus 4 plus 2, and then multiply it with itself. And then distribute. So let me just copy down the left side so I don't forget about it. So the square root of x minus 4 times itself is just x minus 4 without a square root. And then there's going to be that square root times 2. So 2 times the square root. And then we're done with those. And now distribute the 2. So that means plus another 2 square root of x minus 4. And then the last one times the last one is going to be plus a 4. And sure enough, there's still a square root, so we're going to need to square both sides again. But before we do that, we should take all of these other terms, like this one, and this one, and then move them to the left side. Well, I just noticed that the good news is a negative 4 and a positive 4 cancel. So actually all we have to do is move the x over. So subtract x from both sides. So the left side now has x minus 1 equals, and then a 2 radical x minus 4 plus another one means that there's 4 radical x minus 4 on the right side. And then square both sides. You might say, wait, don't you need to move the 4 over? And you don't, because when you square both sides, when I square the right side, I just have to make sure that I square the 4. So when I square the 4, that's going to be 16. And when I square the square root of x minus 4, that gets rid of the radical. And then on the other side, I need to do x minus 1 times x minus 1. Okay, so you can do the FOIL or the distributive property like this big blue blob right here. Or there's a shortcut for that, which goes like this. Square the first thing, x squared. Multiply these two things, which is negative x, and then double the result. So negative 2x would be in the middle. And then square the negative 1 is positive 1. And then that replaces basically that extra step right there. All right, we're almost done. So we have on the left x squared minus 2x plus 1. And on the right, if you distribute the 16, that's going to be 16x minus, does anybody know 16 times 4? I believe it's 64. And then we just need to move everything to the left side. So I could go minus 16x and minus 16x. And I could go plus 64 and plus 64. So that way it's set equal to 0. Cancel, 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 cancel. And on the left side, there's x squared minus 18x and then plus 65. Okay, we're almost done. Now we either need to factor this or use the quadratic formula. So for factoring, I'm just wondering, could it be factored? So are there two things that multiply to be 65? So 65 equals 5 times something. I know that. That would be 5 times 10 is 50 with an extra 15. So that's 5 times 13. Oh, nice. Because a 5 and a 13 happens to add up to 18. So I think we can save time by factoring. So x times x will be x squared. A 5 times a 13 is a 65. And then this symbol means that both signs have to be the same, and they have to be the same as this. So it has to be minus and minus. And then if you double check, this would be negative 5x, and this would be negative 13x, which adds up to negative 18x, which is exactly what it was supposed to do. Perfect. Okay, so now we can solve for x. So since it's already been factored, then you could set this equal to 0. And then that means that x is going to equal 5. You could set this one equal to 0. And then that means x equals 13. But I have to go and make sure. So I said solve the equation. And the thing is, if you go back to the original problem, because it has square roots, this and this should not produce any imaginary numbers. Because I didn't say solve using imaginary numbers, and so we can't have imaginary. So what did we get? X equals 5 and x equals 13. So we got 5 and 13. And if you put a 5 in here, 5 minus 4, that's a positive number. If you put a 5 in for this, that's going to be 10 minus 1. That's a positive number. So the 5 is a keeper. And then if you check the 13, this would be 13 minus 4. That would be an imaginary number. So we're not going to keep the 13. We're only going to keep the 5.